Assalamualaikum and very good day everyone. I am Syam Darwish bin Syamhan as a Group 8 representative. Me, as a first presenter, like to introduce my other three group members. They are Rasmi, Pang and Muaz. Our group will be present about the production of toluene. So, what is toluene? Except for benzene, toluene or toluene as it was originally known is the most basic aromatic hydrocarbon. It's a colorless, water-insoluble liquid with the smell associated with paint thinners. It's a monosubstitute benzene derivative consisting of a methyl group attached to a penyl group. As such, its systematic IUPAC name is methylbenzene. Polish chemists Philip and Walter extracted it from pine oil for the first time in 1837. Henry Etienne, a French chemist, isolated it from tolu balsam 4 years later. Chemists settled on the term toluene for the then new chemical within the next 10 years. Almost the majority of the global toluene demand is met in oil refineries or as a byproduct of ethylene crackers. Similarly, the vast majority of it utilized in the production of other aromatics of as a gasoline additive. Although it is not widely used as a solvent, it's an important component of paints, lacquers, and resins. As a solvent, toluene has mostly replaced the more harmful benzene. Benzene is non-carcinogen, while toluene's carcinogenicity has yet to be determined. Next, what are the uses and benefits of toluene? There are so many utilities for toluene. Firstly is for industrial uses. Toluene is typically used in the production of paints, rubber, lacquers, glues, and adhesives because it can help dry, dissolve, and thin other substances. It's used in the production process to make other chemicals, including benzene, nylon, plastics, and polyurethane, and in the synthesis of trinitrotoluene (TNT), benzoic acid, benzoyl chloride, and toluene diisocyanate. Next is for personal care products. Toluene has been used as an ingredient in nail polish removers due to its ability to help dissolve other substances, such as resins and plasticizers. It has also been used in the formulation of nail products to enable nail polishes, hardeners, and lacquers to be applied smoothly. Lastly is for transportation. Toluene is produced in the manufacturing of gasoline and is also a gasoline additive that can be used to improve octane ratings for fuel use in race cars and other automobiles. The higher the octane number or rating, the greater the fuel's resistance to knocking or pigging during combustion. Toluene is used in these applications because it's dense and contains significant energy per unit volume, which enhances power generation for vehicles. Lastly, how is toluene made? First, making toluene through catalytic reforming. Toluene is made through catalytic reforming by passing a hydrocarbon mixture over a dehydrogenation catalyst. Hydrocarbon gases are removed and an aromatic-rich fraction is obtained from the reformed. Toluene is produced through distillation or solvent extraction, which is the more usual method. It is also possible to produce benzene and xylene isomers through solvent extraction or distillation at different stages of the process. Secondly, making toluene through a steam cracker. Increasingly, toluene is made by a process of steam cracking liquid hydrocarbons such as naphtha and gas oil. The hydrocarbon being used must be hydrogenated before extracting the toluene as it's unstable. Lastly, making toluene in the lab. Making toluene in the lab is very expensive, but it can be done in a student demonstration. For example, toluene can be synthesized by mixing methyl chloride and benzene in the presence of aluminum chloride or other Lewis acid.
Hi guys, I'm Pang Sheng Shan from Group 8 and I'm going to present about the process diagram and mass balance calculation part for our project. First of all, what is flow diagram? A flow diagram is actually a graphical presentation of a procedural system or computer algorithm. They are frequently utilized in a variety of fields to document, analyze, plan, enhance, and maybe convey often complex processes into clear and simple diagrams. They can be as simple as hand-drawn diagrams or complex as computer-drawn diagrams, to illustrating several steps and paths of a process. So as we can see, there is a example in the slide, which is the production of Toluene, which is our project. And moreover, I'm going to present about calculation of a project. So given the data in the block flow diagram, the basis is 1000 kg per hour, and the mole fraction for toluene is 0.9. The moles fraction for benzene is 0.1, and the moles fraction for ethylbenzene C8H10 is 0.92. And last one, for the moles fraction for steam H2O is 0.08. To calculate the mass flow rate at product stream, so we can use overall balance technique to determine the mass balance at number streams. So this calculation is presented in the processing below. So first of all, we can use overall balance of toluene, which is input equal to output, which is we can solve Mn equal to Mn. M stand for mole fraction and N stand for M stand for mass flow rate and N stand for mole fraction. So we can submit M3 times 0.92 and 1000 times 0.9 to calculate the mass flow rate of M3, which is 978.26 kg per hour. Since we get a mass flow rate of M3, we can use that to find the mass flow rate for M1, which is stream 1. M1 plus M3 equal to M12 plus M13, which is equal to the basic that we use, which is input equal to output. So M1 equal to M12 plus M13 minus M3. So we submit a value which is 1000 minus 978.26 kg per hour. So we get the total, which is M1 equal to 21.74 kg per hour. Next, we may use the overall mass balance to calculate the mass flow rate of M12 and M13. So for M12 is 1000 times 0.1, because 1000 is our total output and it is equal to total input. So we get M12 is 100 kg per hour. So for M13 we use 1000 times 0.9, which is the mole fraction of the stream, 0.9. So we get the mass flow rate of 900 kg per hour. Hence, the mass flow rate for the production of toluene at the product stream, which is stream that flow toluene, is 900 kg per hour, and the mass flow rate for the waste stream is 100 kg per hour.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azmin Junaidi. And for now, I proceed to our next slide, which is process description. So, based on the block diagram below, we must get the product for toluene, and we must use ethyl benzene as a substance. So first, in the dehydrogenation process shown in figure 4.4, purified ethyl benzene is preheated in a heat exchanger, and the resultant vapor is mixed continuously with steam at 710 Celsius in the dehydrogenation reactor that contains one of several catalysts. The reaction product exists through the heat exchanger and is further cooled in a condenser and recycled to the boiler. The remaining crude liquid styrene goes to storage tank, and the processed water is purified in a stripper. The hydrogen-rich processed gas is recovered and used as a fuel. Benzene and toluene are removed from the crude styrene in the benzene-toluene column. They are then typically separated by distillation. Okay, and then let's proceed to the first process, which is the input. So, the substance which is the input for the process will get through into the hydrogenation first before flowing into another reactor. Pure ethyl benzene has been preheated in a dehydrogenation reactor before flowing into a heat exchanger. The pure ethyl benzene, which is the resultant vapor, is mixed consistently with steam at 710 Celsius in the dehydrogenation reactor that contains one of several catalysts. Okay, for the last process, which is the output. So, the product which is the output for the process has been separated in the distillation column after the benzene and toluene are removed from the styrene in the benzene-toluene column based on the data flow diagram stated below. In the distillation column, the heat causes components with lower boiling points and higher volatility to be vaporized, leaving less volatile components as liquids. Mixtures with high relative volatilities are easier to separate. This makes separations of closing, boiling, and azeotropic phase difficult, so special distillation techniques have to be used to separate these mixtures. So, after the distillation process, two products result after the benzene and toluene are produced, and the final result toluene used as the main product to get.
Assalamualaikum warahmatullahi wabarakatuh. My name is Rasmin Azri bin Abdul Rahim. So today I want to share you about conclusion. Production of toluene. Toluene is a chemical that occurs naturally in the crude oils and is used in the production of paints, lacquer, explosives, and glues. Paintiness, paintbrush cleaners, nail polish, glues, ink, and strand remover are all examples of toluene in the home. Toluene inhalation, oral consumption, and skin contact. Toluene has a low acute toxicity in the experimental animals. Toluene is categorized for specific organ toxicity after a single dose based on human evidence. Toluene is a skin irritant, although it isn't regarded as an eye irritant. Toluene is very important in our life because toluene is typically used in the production of paint, rubber, lacquer, glues, and adhesive. After all, it can help dry, dissolve, and thin oxidizing stain. Increased risk of the fire and explosion on contact with oxidizing agent, for example peroxide. Not corrosive to aluminium alloys, carbon steel, hazardous decomposition, product knock-on possibility of hazardous reaction. Knock-on. Toluene is a flammable liquid. Use a chemical alcohol resistant foam or another foaming agent as extinguishing agent, as water may not be effective in fighting fire. Other than that, it's critical to keep toluene away from heat and ignition sources. This chemical should be kept in a firmly closed container in a dry, well-ventilated and secure location, particularly one intended for flammable liquid storage. Toluene should be stored away from oxidizing agent and other incompatible compounds. Toluene level of 500 parts per million are deemed life-threatening. Some persons may be more vulnerable to the effect of inhaled solvent than others due to the genetic variation. Some workers who were exposed to the toluene levels regarded safe in the workplace develop occupational asthma. Exposure to toluene in a consumer product can be reduced by using this product in well-ventilated areas and closely following all label warning and instruction.
Next is the advantage to the Earth's creatures. The use of toluene is not good for the environment. As a result, toluene has caused permanent damage to the life in the plants. It has moderate chronic long-term toxicity to aquatic life. Chronic and acute effect on bird or land animals have not been determined. Toluene is expected to minimally bioaccumulate. Overview: the colorless liquid toluene C6H5H3 has a pleasant, pungent odor, eyes and nose irritation, exhaustion, confusion, emporia, dizziness, headache, dilated pupil, chills, anxiety, muscle fatigue, sleeplessness, nerve damage, skin inflammation, and liver and kidney damage are all symptoms of toluene exposure. CNI's depression has been reported to occur in the chronic exposure to approach to the high levels of toluene. Chronic inhalation exposure of humans to toluene also irritates the upper respiratory tract and eyes, sore throat, dizziness, and headache.
Lastly, is toluene hazard information. Number 1 is GSS qualification, flammable liquid category 2, H225, highly flammable liquid and vapor. Number 2 is GSH classification, aspiration hazard category 1, H304, may be fatal if slowed and enters airways. Number 3 is GSH qualification, screen irritation, category 2, H315, causes screen irritation. And number 4 is GSS classification, specific target organ toxicity, single exposure, central nervous system, category 3, H336 may cause drowsiness or dizziness. Number 5 is GSS classification, reproductive toxicity, category 2, H361, suspected of damaging fertility or the unborn child. Number 6 is DSH classification, specific target organ toxicity, repeated exposure, category 2. H373 may cause damage to the organs through prolonged or repeated exposure. And last but not least, number 7, GSH classification, acute aquatic toxicity, category number 2, H401, toxic to aquatic life.